downwards, if you give me a few seconds, to try to, tilt the plane down, right? So I also want to rotate ourselves a little bit so that we can have a good 3D perspective. So now our X2 is, you know, lying down, and there is a sense that the vertical line here is now the profit. We just call it Z. So that is basically 5x1 plus 2x2. Okay. So let's quickly replicate what we have at the bottom. At the bottom, we have until 8. We can do that here quickly. 8, 4, 2, 1, 3, and then we have 6 here, 5, 7. Yep. Okay, then we have we need to now tilt down, right? This particular feasible region, so that our 6 is going to be roughly here. I just do a rotation. 6 is here, and therefore 3, 2, 1, 4, 5 over here. Okay, so this point is in, and we want to have 4,6 and 8,3. So 4,6 will be given by over here. Okay, and we have something like that here. 4,6 is here. Okay, and we need 8,3. So 3, something like that, and 8 over here. So we'll join these 2 points together and basically tilting the entire feasible region to the planar form in this case. Oh, we need 0, 1 over here and 1, 0. So we also need to have this. Okay, so now the whole hexagon, well, not exactly uniform hexagon, but 6-corner polygon is being tilted down in this manner. And I ask for your patience because I want to manually draw it so you can also follow. Right, the point is not for me to show you a finished one to impress you. The point is for you to see how each decision on drawing the line and where to begin and how the line was even thought out, how the lines connect, and how do I even have that line. Each and every step along the way is being open source to you, is being shown to you, so that then you can draw yourself. So the whole point is not to impress you, but to show you the working. And then what happens is that we need to have the heights. Okay, and to have the heights, I need some sort of a maximum. So if I have a 5 here, I have a 5 here. Just make sure I have enough room to draw out. So I call this 50. If I call this 50, right, then I have about 2, 3, 4, 3, 2, 1. So that's 10 here, 30 here, 40, 20. Okay, so if I use this scale, then I'll be able to move it across to I kind of draw a light version because the construction lines, I don't want it to be too prominent. Okay, and so I have so long as I'm parallel, then I must be reaching 50 here. Okay, so I have a scale there. Now 0, 6 is going to use just 12, so I need a 10 line here to guide me, and 12 is probably just a little bit here. And then we have a 32, right? So this point 4,6 is going to be 32. So I need a parallel version. Okay, so this is 50, and this is reaching 50. So I need a 30 that will be a good reference over here and over here. Yeah, okay, so that's 30. And 32 is probably just 50, 40, 30, a little bit slightly above 30. Now, this is for illustration, so I'm not too worried about being totally exact about it, so long as it's not totally way off. Okay, then we need to worry about this um, being 46, and here I need a 50, 50 here. All right, so this point is right here is 50. It's 50, and this is 40. Okay, and I need to then swing it across. This is 50, and this is 50. And importantly 40 as well. Okay, so here 40, and the height is actually 46. So this is 32, and we need a 46 over here. No, this is 40. 46 is probably here. 46. Okay, so this is the point 46, the optimal point. And then what happens? We need this to be 40, and that's easy because we already have it here. So this is 40. Okay, and we have this being 5. So 5, this is 10, this is 5, so about half here. Right, and so that's the vertical line. And we have 2 over here. So that's 10 here. 5, 2, it's hardly, it can be seen, but that's the height of 2 over there. Non-zero nevertheless. So over here we have 1, 2, 3, 4, 5, 6. And we are ready, and we can extend the support, all right, all the way to the point that's covered. That's covered. And this is to be covered here, supported by this here. Okay, and now we are ready to join them up um, by linking this. So this is actually this way, and from a bit of a height to a taller height, because it's from 2 to 5, right? And then we have from 5 to 40 being very prominent over here. And then 40 to 46 as we travel upwards. And then from here down to 32. And from here down to a height of how many? 12. And there you go. We are now able to see the entire volume of the feasible region. Why volume? Because the height information is showing us the profit. And of course, we want the point is the highest. Now the highest point has a lot of meaning. It is not just the highest profit, but also the highest point in this construction. And if you want to say that, hey boss, do you know that your entire business is shown right here? Is contained in this space. That is not wrong actually, given all the constraints. So the plane, all right, shows the feasible region. If we helicopter up to now look downwards from the top, we will see this outline. It's like the top of a building from a map. You only see the outline, right? So this is like outline. And of course, if you land on the street and you look at the same building, you can see that maybe some parts is taller, some parts are lower. And this is exactly what is going on when we perform graphical solution, right? So if you have homework exercises, exam questions that require you to draw a graphical solution to find the optimal solution, or use graphical method to find the optimal solution of the following LP problem, then you must show this, right? The feasible region, construction of the objective function, show the direction of travel, and of course you don't have to draw so many lines, just one or maybe even two, but ultimately you must find the intersection of the most important point, the optimal solution. Okay, so with that, we basically are done with the graphical solution method. I hope you enjoyed the whole process because it's quite fun to be able to see through, right, all the abstractness of the model and be able to uh, pinpoint visually the actual optimal solution. Okay. All right, with that, we'll just conclude this example and I'll then move on to the next part of the lesson.